Okay, hello everyone. In the previous video, we have discussed about the aircraft range. In this video, I'll be just briefly discussing about the ideal ramjet. So basically, a ramjet engine is as shown here. It is a very simplest engine. Like it contains a diffuser, some combustion chamber, and a nozzle. It has no compressor. No compressor is required because like this is operated for a supersonic flow, and then due to supersonic flow once it enters here, there will be an oblique shock. So the flow compresses. So no compressor is required. Because no compressor is required, no turbine is required to run a compressor. So first compression occurs here and then expansion occurs to the CD nozzle. Next, here in the combustion chamber, we usually require flame holders because like the flame will so that the flame will not be blown off. Because like here, if you notice, I have drawn some vortices here. These vortices are the recirculation of the fluid, which is a pool of hot radicals which is continuously generated so that the fuel ignites. And then, as you have seen earlier, ramjet cannot develop a static thrust, and so it cannot accelerate by itself from zero velocity. Now we'll be discussing an ideal ramjet, which is a very simplified model of ramjet by assuming no irreversibilities. The assumptions involved are the compression or expansion process are reversible adiabatic process, and combustion takes place at constant stagnation pressure. And obviously, these assumptions are not that realistic due to the presence of shock and heat transfer. So there may be a heat transfer in this nozzle. So my TS diagram for an ideal ramjet looks like this. First step is an isentropic compression in the diffuser of the inlet, that is from A to 02. From 02 to 04, combustion, which is a constant pressure, heat, and mass addition, and 04 to 06, an isentropic expansion. Here, 3 and 5 are not used because there is no turbine and compressor present. Now, uh, since the exit pressure is equal to the ambient pressure, I can say that this thrust is equal to m dot A into 1 plus F into UE minus U. With isentropic compression expansion process and low speed constant pressure, I can say P naught equal to P naught 6. And if I assume this R and gamma to be constant throughout the engine, I can finally say that my Mach number at the inlet is equal to the Mach number at the exit. Now, how to do the analysis? Now, uh, you can use this to find the exit velocity. And after that, next from conservation of energy to combustion process, we can find the fuel air ratio. And after that, after knowing fuel air ratio, exit velocity, and inlet velocity, I can find the thrust, specific thrust. And TSFC, anyways, I can find, which is m dot f by t or f by t by m a dot, because f is m dot f by m dot a. So, yeah, so anyways, you need not remember all these equations, you just need to know the procedure on how to solve a problem, even in exam. So, all the assumptions what you have used in are Cp gamma variations with respect to temperature is neglected, and also there are no friction or shock losses, no heat addition during expansion compression, and no dissociation of combustion products. Because if combustion products dissociate, my gamma and Cp will change. That's it for this video. In the next video, I'll be saying something about a real ramjet. Okay, thank you.